So today we want to first talk about the differences between definite and indefinite integrals that we've already studied in chapter 5. So when you work out a definite integral problem, your answer is going to give you a number or some kind of value. When you work on an indefinite integral, you won't have just one exact number. What you're going to end up with is a family of functions. And that's because you're not defining those end values. So you are looking at having that general antiderivative that we talked about at the end of chapter 4. All right, so for our quick look back to definite integrals, so when you're integrating with end values, that gives you a definite integral. You're defining those endpoints. So you go ahead and calculate that antiderivative. So you have 6, x to the third power divided by 3. You understand that when you do that plus c, you lose that when you go ahead and define those endpoints. So we're going to simplify this function to be 2x cubed, and we're going to run that from 2 to 4. So I'm going to have 2 times 4 cubed minus 2 times 2 cubed, and a quick calculation there, we have 2 times 4 cubed minus 2 times 2 cubed, and that gives us a value of 112. So when we evaluate that definite integral, we get an actual value there. Now, same problem, but when I don't define the endpoints, I get a family of functions as my result. So I still go ahead like I did at the end of chapter 4, and I find that antiderivative the same exact way. But this time, I have to compensate that if there is a constant, I need to understand what that constant is. So I simplify this down to 2x cubed, but I have a family of functions that could be my result. So instead of just one value, I'm getting a family of values based off of what that c could actually be.